Muy calmado, tranquilo. Bueno, quan em digueu. Okay, so hello everybody. I think that there is more people in streaming, so let's start the presentation from HP, right? So I'm Jordina Torrent, so I'm the artificial intelligence lead in large format printing. There is other people that is working with me here, and is helping you on the challenge. And maybe I will explain a little bit. Let me show you the overview. What is large format printing? That maybe some of you didn't know. I think that there is a lot of people from 3D printing, which is a little bit more maybe easier to understand. But I will explain very, very briefly what is large format printing and which are the kind of projects that we are doing at HP, right? Projects that are very focused on artificial intelligence and machine learning, which is a hot area right now, and I'm sure that you will know it very well. And I will explain some of the use cases like plot categorization that were already done by the business, defect detection, proactive and predictive support. So these three projects are more related to our hardware, our printers. It's AI, but it's applied to which kind of data our printers are providing us. And the last one, which is called construction services, is a huge roadmap that we are building right now at HP. That is quite focused on helping AC professionals to develop their job, right? It's more a software-based projects, but that's true that the one that I will explain here, which is called HP Cyprint, is a mix of robotics and AI, right? So you will see more or less a mix of all what we are doing. So, okay, very briefly, what is large format printing, right? So I'm sure that you already see on some of the, not sure, maybe through internet, these very big large format printers, which are mainly used for several things, like I show you here. So are used for printing banners, are also used for printing posters, wallpapers, these kind of huge murals, and also for card wrapping, which is another application of large format printing, and a lot of things for printing architectural drawings that you will see in the last project, maybe printing some electronic circuits and all these kind of things that you can see here. So there is four main paths of business for large format, which is printers that we have at a small office or home office, otherwise that are just sell to enterprise, small and medium printer service providers, and then this quite very big printing business. Okay, so that's an overview of the hardware that we already have a large format, and then let's go to the projects. So the first one, which is called plot categorization, I'm sure that you already see and you have done a lot of Kaggle competitions about how I can classify images like cat versus dog, which ImageNet and all these kind of things. Not only 2 classes, binary class, but more, like 10 classes, 20 classes, or even 100 classes. Okay, so the problem that we just tackled, this is a very, I think, nice project because it's like we just need to build a model that we will deploy inside the printer, right? It's not the same, but when we just build a model to deploy it in the mobile phone, but we will deploy it inside the printer. So the main problem statement for that project is that, okay, can we know exactly what our clients, our customers are printing so that we can improve even more the customer experience when they are just interacting with the printer, when they are just, let's say, fine-tuning the printing settings to automate the printing process and provide a little bit more, engagement from the customers, right? So we have like some predefined classes, more than 25 classes that comes from marketing, which are some of them that you can see here that I already talked about, posters, orthogonal maps, architectural drawings, and we just want to classify them. So that means that when a customer is trying to print something, we'll pass through the firmware of the printer, and then we will pick the raw image and we will try to classify it. And the classification will be uploaded in the cloud, right, in AWS. So how we are doing that? That's not, I will not enter into too much details. I'm not sure if you know something about knowledge distillation, but this is more AI focused, right? So when you want to build like a classification model, you can do several things depending on the classes that you have, right? And on the heterogeneous and the variability of the classes. So you can build like a model which AlexNet, BGG, maybe ResNet or something like this, that is a little bit more, let's say, straightforward. Or you can pick like a more or less huge model like Inception, DesNet, and all these kind of things. Okay? What happens when you have a huge amount of classes and you want to pick like a big Inception model, the model grows a lot, right? Because you are training the model with a lot of data. What happens that if you try to pick that model and put it into the printer's firmware, maybe it will explode, right? Because inside the printer you will not have any GPU. Okay? The only thing that we have that you will see in the next slide, let me explain it together. So what you will have will be like the CPU, which is not too much powerful, and an FPGA, right? And you need to use these hardware components so that you can make the inference and the prediction. That means that your model needs to be, let's say, small enough so that the printer can do it in, not in real time, but very fast without using too much resources. So what we are doing here is like we are applying knowledge distillation because we have a huge amount of classes. We want to be like a huge model, which will be the teacher model. And then we want to pass all the knowledge that we have from the teacher model, from the teacher model to the student model, which is the smallest model. And this is what the knowledge distillation approach is doing, right? So what we have here very briefly is like a loss function that allows us to compute the cross entropy between the two labels and the softmax function from the student plus another cross entropy that allows us to compute the softmax function of the student and the teacher as well. If we are minimizing this loss function, what we will do very briefly is that part of the most important knowledge of the teacher model will pass through the student model, so that we have a very small model that we can deploy inside the printer, right? This is a kind of framework that we have, so we just selected that printer, which is the HP Wi-Fi patchway, which is also called Typhoon, right? And we put the model inside the printer's firmware, right? So here what you have is the image that comes from the raw image, then we just compute a thumbnail, which is let's say a compressed data from the image, and then we are just applying here the inference using OpenVINO, which is a kind of, let's say, library or framework that allows us to do this kind of deployment inside a specific hardware. Okay. So that's the first project that I wanted to show you. The second one, which is more related to, maybe then they can ask some questions, right? So we can make all the presentation and then they can. Okay, so the next one is the defect detection project. That project is very focused on trying to, okay, it's also focused on the printer, right? On the hardware, but it's trying to detect some defects when the machine is printing, right? That means that we need to detect these kind of defects in real time, which is quite difficult, and with the hardware that we have. So what we just propose is that we make like a large format printer. We put some scan here, which is called the Baccarat one, and then this camera tries to, let's say, make some photos about what is printing in real time, and then so that then we can detect this kind of defect. So this is mainly used for print quality monitoring. That means that if the customer is not aware that maybe the printer has some issues internally, okay, we can make like a monitoring tool so that we know exactly when we need to stop the printer jobs so that the customer can reduce the cost. And then we can detect this kind of defects and provide them like a most optimal troubleshooting, right? So let's see how we are doing this. So these are the kind of defects that we have in large format. It's not, you cannot appreciate very well them here, but there is gray, there is dark light, and white dark banding, which is this kind of, not sure how to say, banding that you can see like a wavelength, right? So these are the most difficult defects to solve in our printers, and what we are applying here is not a, let's say it's not a deep learning model, but a machine learning model that works quite good. Okay. So what we are doing is you have this kind of wavelet things. So we just decided to apply Gabor filters and the fast Fourier transform. So what we are doing is picking this kind of photos that the background sensor is doing. And then we are just processing that photos. I'm not sure if you can see it here, but we are picking this kind of regions in RGB. Then we are computing in the frequency domain several features like the Gabor filter and the fast Fourier transform, discrete fast transform. We are applying different kernel sizes. That means that if we have a region, we want to apply Gabor filter in a kernel size of 3 by 3, 5 by 5, or 7 by 7, and so on. And then what we are doing is a kind of feature extraction. Once we have the convolution between these kind of patches, the original ones, and all the images that we get from the frequency domain, then we just extract some features that are mainly based on our statistical moments, the skew kurtosis, mean, standard deviation, and so on. And then we make a feature selection. You can apply any algorithm here. They work quite fine. And afterwards, a supervised classification. So what we are doing is supervised classification here, because we have all these kind of images already annotated. So for every patch, we have the ground truth, right? We know that this is grain and where the grain is located. We know exactly where there is Darla-John banding and in which location of the patch is exactly the Darla-John banding, so that we can apply supervised classification. So here we just did light GBM, but you can just change it for an SVM or something like this that will work also quite well. Here the tricky part was that one. You can see that this was relating all these kind of features in the frequency domain with our defect, which is also related with the banding. Okay, let's go to the other one that is quite related to defect detection. So I think that you just maybe read something, or there's another competition about predictive support, right? Predictive analysis or proactive analysis. When we want to apply that, imagine that you have like a printer that is reporting some defects like the ones that I just showed. And you need to contact the customer quite fast before the printer crashes. That means that you are detecting defects on the images. Maybe you have some data from the printer. When I say data, I mean system errors that we will see here, so that you can mix box together and you can make a prediction saying that, okay, maybe in 1 week, you can say that to the customer, maybe in 1 week the printer will crash or something will happen. There will be maybe a media advance error, or there will be another kind of error, not sure, related to inks or the print heads of the printer and these kind of things. So what we are doing here, as I mentioned you, a predictive and proactive support allows companies to fix issues before they actually become problems, right? So what we don't want is that the printer crashes and we don't know exactly why. and unexpectedly, the customer call us, the HP support, and say, okay, this is crashing, I'm not sure what is happening, but I cannot use the printer. So we want to avoid this. So what we're doing is like, okay, which kind of data we have here? So we have images like the ones that I showed to you, the scans, and then we have these kind of logs that the big data team is storing in our EWS databases, right? Which are logs, traces, where some errors are explained, otherwise not, or maybe there are the ones that we will use for making predictive and proactive support that are called system errors, that are specific codes of the printer, okay, that can be extracted from these kind of logs and also from customer support cases to understand specifically the health of the printer, to know exactly which is the state of the printer at one specific time, okay? So what we are doing with this kind of data, with system errors, right, that the printers are reporting us every day. So we can do several things. What we want is to detect specifically which kind of error is, right? To relate that error with the issue. Imagine that we have an issue on the defect. There is one error from the printer that tells us, okay, this kind of defect, so you will have like grain or Darla-John banding very soon, because the error is still, it's becoming to appear, right? And then you can relate, okay, I have this error, I have the meaning of that error, let's say like that. It's a defect related to Darla-John banding, and then I want to troubleshoot it, right? But to do all this part, what we need is to extract these kind of system errors from logs that are this huge amount of text that our printers are sending to the cloud, right? So for doing that, what we are applying here is like a name entity recognition model, okay? So that we can recognize system errors, that are the ones that you can see here, as an entity, okay? And we can extract that, and then we can process and do other things. This is the kind of model, I'm sure that you read about this. You need to prepare the data a little bit to clean the unwanted text. This is like an NLP problem. It's not related with computer vision than the ones that I showed to you, but it is more a natural language processing problem, right? So what we have here is a pre-trained model, then we apply token to vector, right? So that we can create an embedding, and then we can classify and detect specifically this kind of pattern. What we will do with these kind of errors, right? Because it's nice to have it, but then if you want to proactively say to the customer, okay, there is something that is happening here, you need like a trigger, right? You need to detect a set of system errors, a pattern of system errors, so that you can say, okay, when I have, maybe when the printer reports me 3 equal system errors in a range of time of 1 day, that means that something huge is happening inside, right? Something dangerous. So what I need to do to make a trigger or launch an alarm to say, okay, the HP support needs to contact to the customer very soon because otherwise the printer will crash. For doing this kind of things, this is what we call automatic rule creation, right? We are creating a kind of rules based on that particular system error patterns so that we can say, okay, when we have, so let's say we define the rules as a threshold and a time delta. What does it mean that? That if we want a rule to be triggered when there is some dark legend banding in the printer, right? What we'll need to do is to associate that particular system error, the system error for the dark legend banding, to say, okay, if 5 different system errors appear in a time range of 2 days, and these system errors are related to something that is more or less equal to dark legend banding, that means that you will have this defect maybe in 1 week, right? So we need to create these kind of rules because we don't know exactly, we cannot control exactly the behavior of the printer. That's the point, okay? Because the behavior of the printer is changing depending on the environment, depending on the media, on the paper that the customer is putting, depending on the printers, and depending on a lot of variables that we cannot control. So we need to create this kind of, let's say, automatic rules or rules in real time so that we can say to the customer, okay, let's wait, let's stop the printer because we need to do some kind of troubleshooting so that the printer will not crash in 1 week, okay? What we are doing this, so this is the reason why we are defining rules as a threshold, a time delta, so that we can apply here a recurrent neural network, which can be based in LSTM models or another kind of things, or true models, and we can process this time delta in a Windows frame so that the model, the output of the model will be, okay, a new rule is created, and this rule will be associated to dark legend banding, right? And the rule will be defined by this threshold equal, imagine, threshold equal to 3 system errors, and the time delta equal to 1 week, okay? And this is the kind of things that we are using in support services so that we can generate automatically the alarms. Okay. So let's move to the last project, which is, as I mentioned to you, it's not focused a lot on hardware, it's more focused on software, okay? And it's based on construction services. This is a roadmap that HP is defining, a very huge roadmap. I can only show to you one project because we cannot disclose anything. There is another one that is fully based on AI that I cannot explain, but it's very nice. There is some people here that is working in this, but I will show to you one that is also very nice, which is a kind of printer, right? It is like a robot, like a Conga, okay, that is printing in the floor, and we put some AI there as well, okay? So what we are building the roadmap, let me explain to you also the reason behind this, because you know that HP is a business that is very based on hardware, right? We have a very, I think that a past experience on hardware, like ABM has, and we need to make this kind of digital transformation from hardware to software, right? This is the reason why we are doing this kind of projects. That's true that we want to launch software services in the cloud, But that's also true that we want to also take advantage of all the knowledge that we have in hardware so that we can build these two worlds harmoniously. Okay, and this is what you will see here. Okay, let me explain to you a little bit HP SitePrint, which is that project that we just launched, I think, at the beginning of the year, or more or less. It's quite new. You will see a video afterwards. So HP SitePrint is like, you know, when a building is made, right? There is some guys which are called layout experts that are picking the drawing plan. Imagine that you want to build a flat, right? They are picking the drawing plan and they are manually drawing that plan in the layout. So then the construction company can just build the walls based on the guidelines that the layout experts are doing. Okay? So these kind of layout experts are very scarce, and this is a very manual job that we want to avoid, right? Because we want to make like buildings faster, more optimal, and with more precision, right? This is HP SitePrint wants to at least improve, right? So you have this kind of robot that you will see in action in some of lights that are just moving through the floor, through the layout, through the floor, and it's just printing all the layout, all the skeleton of the drawing plan. Okay, so that then you can build the walls automatically, just following these guidelines. Okay, this kind of robot, let's say, it's not only, that's the key point, it's not only printing the layout, it's not only printing the drawing plan in the floor, but it's also have some AI so that they can, you know, detect obstacles and do this kind of fun stuff, right? Detect obstacles, or imagine that you have two different robots and you want to plan which kind of robot needs to do, because I want to maybe just draw the layout with one robot or this part, and the other one needs to clean that. So that we are trying to introduce AI so that we can interact with each one or the other one. Okay. So another thing that is a key point of all this process is that you have a very clean drawing plan. Okay, when we are talking about restoration and all these kind of things, what you have is like a drawing plan which has a lot of noise, and this drawing plan cannot be processed by this robot, which is called Motus, okay, that we have. So we need to clean a little bit the drawing plan and then send the drawing plan to the robot, and the robot will print it, okay? Well, how we are doing this? So we are applying GAN models. I'm not sure if you are aware of that, generative adversarial networks, so that we can remove all the noise in a supervised and unsupervised way, and the drawing will be clear, okay? You can not only apply GANs, you can also apply the diffusion models that are quite new right now. Okay, but this is what we are doing in this kind of thing, so that we can have a clean drawing plan, and then we can send that to the robot, and the robot will print it very well. Okay, so let me show you. I'm not sure if I'm running maybe to start. So let me show to you. Yeah, we can just jump to the other one. Let me show to you this robot in action, right? I'm not sure if they will see it, or we need to maybe close the lights. Not sure. Let me try. Okay. This is part of the drawing Okay, so that's all I wanted to explain to you. If you have any questions, so feel free to ask me after the video. That's nice. Okay. No. It's already tested in an early access program, and we are just assessing that and selling that to the customers.
And so, is there any building that has been built using that?
Not yet. Because we just launched the project, I think, 3 or 4 months ago. So not yet. But that's because that there is a high demand from AC professionals who have these robots, and more of them, a fleet of robots, so they can speed up the construction part. Yeah. And we are just improving that robot in every week in an agile manner, because we need to introduce a lot of AI things regarding crime, energy identification. Because the robot has I just jumped to the video, but the robot has an RGB camera, an IntelliSense camera, so that we can catch point clouds and we can detect objects from 3D point clouds. And then the objective is that we can map the 2D drawing, right, with the 3D point clouds that you have, make like a mapping, 2D from 3D, an alignment or a registration, so that then we can monitor the construction site, right? And say, okay, 10% of the building is already made, 20% of the building is already made. There is some issues, there is some defects that we can detect in the point cloud that are not in the drawing. So how we can manage that, right? And this is what is still drawing the project. Okay. You want it? Yeah. Thank you. Bueno, cortáis el stream, ¿no?